Hello and welcome. This is a series of videos where we are going to discuss selected but challenging problems of JEE Advanced 2020 Paper 1. In this series, there are total 8 problems and we shall discuss one problem in each video. We shall upload videos on consecutive days today onwards at 3 p.m. IST. So needless to say, stay tuned with us. Now let's start with the first problem. We are given a function f(x) is equal to mod x into x minus sin x, and we need to figure out where the function is 1 1 or many 1 and into or onto. The very first thing we quickly observe that the function is an odd function because it is the product of even and an odd function, or in other words f negative x is equal to negative fx. So now the question is, how is this observation useful in the problem? Notice that by figuring out the oddness of the function at the starting, we need to analyze the function only for non-negative values of x or only for non-positive values, whatever we want. Because an odd function is symmetric about the origin, so if it is 1 1 for non-negative x, then it would be 1 1 for all real x. Now probably you have realized that recognizing oddness of fx is helpful in reducing clutter. Figuring out 1 1 or many 1 of a function requires to check the monotonicity of the function. By definition, 1 1 functions don't give the same outputs for 2 or more distinct inputs. Consequently, if a continuous function is strictly monotonic, it must be 1 1. The given function fx is continuous because it is the product of two continuous functions. So checking its monotonicity is enough to figure out whether it is 1 1 or many 1. Derivatives are helpful in figuring out the monotonicity, so we find f dash x. It is a standard result that a function is increasing in an interval where the derivative is non-negative, otherwise it is decreasing. But to find those intervals, we need to know where f dash x becomes 0. Such points are called critical points because they are the point where a function probably changes its monotonicity. But in this case, we are not able to solve the equation f dash x is equal to 0. So we abandon this approach and seek other way to figure out monotonicity. This time we closely inspect fx. Instead of checking the behavior of whole function at a time, first we check the behavior of its second factor, x minus sin x, and we let it be gx. We quickly deduce that gx is a strictly increasing function because its derivative is non-negative, and since g0 is equal to 0, so gx is non-negative for all non-negative real x. Now we see fx as a product of two non-negative strictly increasing functions, and the product of two such functions must be strictly increasing, in fact non-negative too. You may want to pause the video and try some time to ponder why this holds. Try to come up with a precise justification, and if you want, you can ask in the comment section. Well, in this way we have proved that fx is a strictly increasing function on the interval 0 to infinity, and since fx is odd, so fx is strictly increasing for all real numbers. With the consideration of continuity of fx, we finally deduced that fx is an 1 1 function. Half of the job is done. In order to figure out for into or onto, we need to find the range of fx. As we have already noted that f is strictly increasing, so we should find the values of fx at boundary points. We observe less formally that f infinity is infinity. In formal words, we say that fx approaches infinity as x approaches infinity. In this way, we find the range of fx, the set of real numbers, and hence we conclude that f is an onto function. Therefore, we get option C as the answer. This completes the solution. So this was a nice problem which spots the blind lovers of derivatives. Blind lovers of derivatives might be banging their heads in finding the roots of f dash x is equal to 0, which is not a feasible approach as we saw in the first attempt. The key idea in this problem was the observation that the product of two non-negative strictly increasing functions is a strictly increasing function. Once you get this idea, the rest of the work is routine. That's it in this video. If you want to study the classification of functions in detail, we advise you to follow our book Algebra Volume 1, where we have given this topic in great detail with plenty of problems. This is our next problem. Make sure you attempt it before watching its solution. Thank you for watching the video. See you next time.